Welcome to our open source session at Build. We have some exciting news and demos to share with you today. I'll share with you our open source journey at Microsoft and how we built Azure as an open cloud so that you can build and run apps with your favorite languages, platforms, integrations, and databases while still optimizing IT costs. I'll then turn it over to our other fabulous speakers to cover the flexibility of deploying cloud native applications and how to unlock innovation faster using AI and data. At Microsoft, we're committed to open source software, and we're working on a culture that embodies open source values. Our developers are using open source software to get their jobs done more effectively. Virtually every team at Microsoft is involved with using or contributing to open source software. You can see this in the numbers. And yes, these numbers are real. So the first number is 60,000. That's 60,000 unique open source software components that we use at Microsoft. And because we use those in multiple different places, different teams might use them or we might ship them in multiple products, we have 9.5 million different instances of those components in use that we're tracking. Open source is about creating an open mindset, collaborating and contributing to software to create added value and to build on the work of others. We collaborate with communities and partners and our customers to bring the best of technologies to helping organizations and individuals to achieve more. Microsoft's contributions to open technologies span across multiple areas. A few examples are highlighted here. Linux has played an outsized, unique role in the development of open source culture at Microsoft. Our upstream contributions to the Linux kernel span over a decade. We contribute to the Kubernetes ecosystem with projects like Dapr or Open Service Mesh to make Kubernetes more enterprise friendly. And we continue to make upstream contributions to a variety of programming languages, web frameworks, and technologies like .NET, Node.js, Python, PHP, and many more. .NET is ranked as the #1 most loved framework and has more than 5 million active developers on GitHub every month. Our mission is to enable organizations and individuals to achieve more, and open source is a very real part of the solution. By creating open solutions, we enable our customers to build on the work of others, to innovate more, to achieve more. Based on the McKinsey research, open source software adoption is the biggest differentiator for top performing organizations, both in terms of innovation and for developer retention. We're actively seeing the benefit of adopting an open source mindset, and so are our customers. Our customers are driving their digital transformation journey using open source and driving significant benefits from investing in open source software technology. I'd like to highlight 2 examples of customers that benefited from adopting open source technologies. The first one I want to tell you about is Bosch. Bosch was looking for a cloud option to run their core business logic with 0 changes on top of a new infrastructure. AKS offered a simplified managed Kubernetes service in the cloud without needing to manage infrastructure. The developers were able to use the open source tools they are familiar with and love and run the solution virtually without any code changes. The other one I'd like to tell you about is Shell. Shell was looking for an intelligent cloud with an intelligent edge that could use machine vision to automatically identify and respond to safety hazards in near real time. Shell was looking for a cloud platform with the fastest response time, with the tools necessary to get the job done. Shell deployed several open source technologies, Azure Databricks with the latest version of Apache Spark for analytics, GPU processing in the cloud, an end-to-end DevOps pipeline, Apache Kafka for streaming, and an open source computer vision library for their deep learning machine vision applications, OpenCV. Azure provided the right tools for the job that work together in seamless fashion. No single person can make the progress that we can all make together using software in the open. Open source has fundamentally changed software development. We're excited to show you how we're making Azure the best cloud for developers. Azure can help you innovate today, tomorrow, and in the future. We're constantly providing capabilities that can help meet your needs to work with open source. On Azure, you can run multiple apps and increase workload performance and security, all while optimizing your IT costs. Over half of all the cores our customers run on Azure are running Linux, and we are heavily invested in enhancing the performance, reliability, security, and resiliency. You can build on your terms using your favorite tools, favorite languages, and your favorite third-party integration. And lastly, we want you to focus on building your application and not your infrastructure. Azure provides you with enterprise-grade managed open source software databases, analytics, and ML services to bring AI to your application. Azure embraces 3 core principles: collaboration, security, and flexibility. Azure's collaborative. Our goal is to empower developers to innovate and help them achieve developer velocity through providing best-in-class tools and environments built for collaboration. Azure is secure. Nothing is more important to us than trust, particularly when you're talking about the cloud. We spend $1 billion a year on cybersecurity, with 3,500 cybersecurity engineers to protect your data and business assets. And lastly, Azure is flexible. We know developers, and we know that they have applications in a variety of locations, on premises, in the cloud, or at the intelligent edge. Azure gives you the portability to move your apps without changing a line of code. The open source ecosystem includes solutions from many vendors and communities. We strive to make Azure a great platform for our partners to jointly build and support their solutions as managed services for our customers. Today, we create a seamless experience across operations, identity, security, and billing to simplify life for our users. Let's hear directly from one of our partners on their experience partnering with Azure and what we've built together. We are pleased to have Elastic join us today. Osman, the stage is yours.
Thanks for tuning in. We're happy to share that Microsoft has been a great partner working with Elastic to help us provide the Elastic Stack natively in the Azure console. It's extremely easy to get started. Simply search for Elasticsearch in the Azure search bar. Then create a resource just like you would any other Azure service. From here, type in a name, pick a region where you want Elastic deployed to. You can change a few other settings like enable automatic logs collection, so data is sent directly into your cluster. And then hit create. Once your cluster has spun up, you'll be able to view the details directly in Azure. From here, you can easily launch Elastic to view Azure log data that you just ingested. You can also make changes directly into the Elastic Cloud console as well. Here, you can make more advanced changes like enable auto-scaling or just resize your cluster if you need to. Back in Azure, you can click into monitored resources to see a list of all the services that are currently being monitored. And under configuration, you can see some more advanced level settings that you can change. So if you'd like to resize your cluster, enable monitoring, or even enable some traffic filters like private link or set up an IP rule, you can do that here as well. So that's a quick demo of the Elastic on Azure native integration. For more information, please check out azure.com/elastic, or be sure to check out the partner showcase. Thank you.
Thank you, Osman. We're very excited to announce the new Elastic on Azure native integration to allow customers using Elastic services on Azure to access integrated billing, full technical support, and Azure portal integration. I'm now going to turn it over to Donovan Brown to walk you through your cloud native journey using open source on Azure.
Thanks, Stormy. Every day, more developers are innovating faster using cloud native development. Azure eliminates the friction of modernizing and migrating your applications to the cloud by providing flexible infrastructure. Azure is a platform that provides efficiency, scalability, portability, and built-in monitoring to detect problems before they impact customers. This allows developers to focus on delivering value using Agile and DevOps best practices. At the center of many microservice architectures is Kubernetes. Here at Microsoft, we combine our development tools with Azure to create a highly efficient inner loop for cloud-native development. Everything a developer needs, from source code management, editors and IDEs, infrastructure as code, container registries, and CI/CD tool chains, all designed to work together. This empowers us as developers to move code from our dev machines to production with a simple commit. We are dedicated to supporting the vibrant ecosystem around Kubernetes. We work closely with open source communities such as CNCF to share our knowledge of working with enterprises and to contribute to the future of Kubernetes. Thanks to Dapr, writing microservices does not have to be hard. Dapr is an open source project that takes care of the heavy lifting. You need to save state, retrieve a secret, or call another service? Just make an HTTP or gRPC request and Dapr takes care of the rest. Dapr offers building blocks to help developers overcome common challenges when building distributed applications, including service-to-service invocation, secret and state management, as well as input and output bindings. Not a single line of your code has to change to move from your dev machine to the cloud or edge. Dapr also offers observability and security features and conforms to standards to help you follow best practices. If you have ever wanted to run a piece of code in response to an event and scale without having to worry about infrastructure, Azure Functions are for you. Azure Functions enable event-driven, serverless architecture with an on-demand, consumption-based cost model. Azure Functions also offer increased agility, improved resilience, and scalability. Collaboration, security, and DevOps best practices are essential to a team's success. GitHub has defined the way developers collaborate and is used by over 60 million developers. GitHub enables teams to take an end-to-end view of the security from source code to deployed solution. And this entire process can be automated using GitHub Actions. What I'd like to do now is show what is possible when we combine Azure and our developer tools. I'm going to take a Java app built using the new Microsoft build of OpenJDK and deploy it to AKS using GitHub Actions. It uses Dapr to fetch tweets from Twitter and scores them with Azure Cognitive Services. Then, the tweets are stored in Azure Storage and published to Azure Service Bus before being shown to users. Dapr makes this all possible with simple HTTP requests. Let's go. One of the cool things about Dapr is you can use it with any language, even languages that haven't been invented yet. If your language of choice can make an HTTP or gRPC request, you can use Dapr. However, if you prefer using an SDK, they are available for many languages. I decided to write this application in Java using the Microsoft build of OpenJDK that is a drop-in replacement for any OpenJDK you might be already using. We also ported the OpenJDK to Windows on ARM and the new MacBook M1 devices. As a developer of this application, task number 1 is figuring out how to get tweets from Twitter. Thanks to Dapr, I did not have to learn the Twitter APIs or install any SDKs. I just defined a Twitter binding with a query, and when a tweet is sent that matches, our service gets called. I simply wrote a post method and Dapr delivered the tweets. On lines 39 through 44, I am setting the URLs to use the Dapr components. HTTP request to these URLs will allow me to call another service, store state, and publish events. When I'm running locally, I will be using Redis for my state store and PubSub. However, when I deploy to Azure, I will be using Azure Storage and Azure Service Bus. But notice, there is no need for Redis or Azure-specific code because I'm using Dapr. Here is an example of a service-to-service invocation. I am using the standard HTTP client class to issue a post request to Dapr. Dapr will find the other service on the network and call the desired method for me. The service on the other end just defines a method that accepts a post request to the same route. Services don't even have to know they're being Daprized to reap the benefits. Services run with Dapr will get observability and tracing for free. Storing state or placing a message on a topic can all be accomplished by making an HTTP request to the correct endpoint. Let's run the application locally. I have already started the viewer and processor services. Now I'm going to run the provider using Dapr so it starts getting tweets. With Dapr streaming logs from all 3 services, I feel like a TV show hacker. Switching to my browser confirms that the 3rd service is processing the tweets from the Dapr PubSub component. With my local testing complete, it's time to move the code to Azure. Because I'm using Dapr, I don't have to change a single line of my code. All I have to do is update the component configurations to point to Azure resources. The same is true if I move my code to another cloud or to the edge. I'm going to deploy my entire solution, including my infrastructure, using GitHub Actions. My infrastructure will be deployed using Bicep, which is a language that allows me to implement infrastructure as code. Infrastructure as code is a DevOps best practice where you codify your target infrastructure and automate its deployment. Using GitHub Actions, I can also codify my entire workflow using YAML and target macOS, Windows, and Linux. This is a GitHub Actions workflow that builds Docker images, deploys the infrastructure, and installs the application using a Helm chart into AKS. Because this workflow can be triggered every time a developer commits code to a repo, we can implement continuous integration, or CI. CI is the practice upon every commit the code is downloaded, compiled, tested, and packaged for deployment. Here in GitHub, picking a run will take us to the summary. Notice we build 3 Docker images and deploy infrastructure at the same time, drastically reducing the time to execute the workflow. You can review the individual steps and logs by selecting a job. For instance, here is a step that used the Azure CLI to deploy our infrastructure using Bicep. Examining the deployment job illustrates how flexible GitHub Actions can be. There is an entire marketplace with thousands of actions that you can use to build your workflows. If you don't find what you need, you can always create your own or you run a custom script. For example, in the Get IP step, I was able to query the IP addresses of the services exposed by AKS using a PowerShell script. Clicking the first address will take you to the viewer now running in Azure, reading tweets from Azure Service Bus instead of Redis. This is one example of how easy it is to move your code from your dev machine to the cloud without changing a single line of code. The second address allows us to review trace information automatically provided by Dapr using Zipkin. Here is a trace of a tweet entering the app from the Twitter input binding, being scored by the sentiment service, saved to the state store, and making its way to the viewer. This level of trace information is invaluable for troubleshooting microservices and is provided automatically when you Daprize an application. Writing microservices no longer has to be scary. Combining the power of Dapr, GitHub Actions, and Azure enables anyone to build and run microservices at scale. Today, we're announcing the general availability of the Microsoft build of OpenJDK for Java 11. This is a new long-term support distribution that is free, open source, and can be deployed anywhere. You might be wondering, why? First, because we run over 500,000 JVMs here at Microsoft. We use Java for LinkedIn, Minecraft, and many other internal systems, including managing Azure infrastructure. Secondly, we have many customers using Java. Having our own build of OpenJDK allows us to quickly respond to the needs of our customers and internal teams. This also enables us to participate and contribute back to the Java community. To learn more, visit microsoft.com/openjdk. Now it's time for Sarah Novotny to reveal how you can unlock innovation faster by using our open services and applications.
Thanks so much, Donovan. I'm Sarah Novotny, and I can't wait to show you how to use the latest AI in your applications to both enhance and innovate faster. I'll give you a quick teaser though. Microsoft's here to guide you on your entire AI journey. We are empowering every developer and every organization to harness the full potential of AI. Azure ML allows you to build AI on your own terms in the framework of your choice. You can build, train, and deploy ML models using open source Python machine learning libraries and platforms. You can manage and track end-to-end machine learning lifecycles using MLflow, remove performance bottlenecks using Pytorch Profiler, and deploy it anywhere using the ONNX runtime. ONNX runtime is a high-performance inference training engine compatible with your favorite ML frameworks and supports accelerated training of transformer models, making them 45% faster. We want to ensure that organizations can build their ML models with the full confidence, knowing that they own and control their data on a platform which adheres to some of the industry's strictest policies and privacy standards and has most comprehensive compliance portfolio of any cloud provider. Our ML toolkits are fully open source and allow you to understand your model and build for fairness, protect data privacy, and confidentiality, and to control and govern everything through every step of the ML process. We're putting responsible ML principles into practice and enabling data scientists and developers to innovate responsibly. AI is not nearly as valuable without data. And that's why we have open data sets. We want to empower you to innovate faster by focusing on the work unique to your mission and differentiation. These public data sets are accessed via an API and include public domain data for weather, census, holidays, public safety, things like that. When you need to add your own data sets to the mix, you can store it in our fully managed open source databases. We give you the best of both worlds. All the benefits of true open source communities, coupled with the enterprise-ready features such as scale, high availability, security, and global reach with our fully managed Azure databases. You can focus on building your mission-critical applications and let us manage your databases. Let's see a demo of this AI in action. We'll be using Pytorch Profiler, a native Pytorch performance debugging tool, to efficiently analyze and troubleshoot large-scale deep learning model performance to maximize the hardware usage of expensive computational resources. We will then show you how to optimize and deploy anywhere using ONNX runtime. Both of these open source projects are made possible due to the partnership and contributions of both Facebook and Microsoft. Over to you, Elena.
Thank you, Sarah. Let's see how Pytorch Profiler open source project developed in collaboration with Facebook could help us collect data, analyze it, and find bottlenecks. Profiler comes pre-built into Pytorch itself starting from version 1.8.1. It's very easy to use. We just need to add few lines of code in our notebook, import Profiler, and set Profiler session parameters. We could run notebook and immediately switch to TensorBoard. TensorBoard is fully integrated now with VS Code. We could launch it right there as part of Python extension. And as we see visualization from our run, we could immediately switch to Pytorch Profiler, which is one of TensorBoard plugins. And we would see overview window, which provides high-level aggregated data based on activity. We could see here kernel invocation, mem copies, data loader, and so on. And we could also see data aggregated by our model training step. In this particular ResNet 50 example, data loader seems to take a lot of time, significant time comparing to our activities in each and every step. And that presents potential bottleneck. As we could see, Profiler was able to recognize that problem and provide us actionable recommendation. In this case, it offers me a solution of increasing number of processes that actually load data into my model. So let's follow recommendation and increase number of workers to 4. Once I run the updated script and collect data, I see that data loader is no longer taking significant amount of time across my steps. And it's even a decreased average step time for each of my model training. So indeed, this performance recommendation made by Profiler helped us eliminate performance bottlenecks in our program. Let's take a look at more advanced views of Pytorch Profiler, trace view. It captures and shows activities across both CPU and GPU devices. In fact, Pytorch Profiler is first tool in the market that shows both PyTorch and hardware activities in the single pane of glass and provides easy ability to correlate between them. First thing we could notice that every step in our training is now depicted as separate highlighted block, which makes it easy to navigate and zoom in each particular step. Let's take a closer view. As we zoom in, we see GPU activities presented on the timeline, and we could see that for some time GPU was idle here, which is not good. Low GPU utilization pattern is one of the things that we need to look out and try to optimize, as GPU is very expensive. Let's take a look at the first GPU invocation here. That's memory copy invocation, and we could see, once we click on it, dependencies and what was happening prior to it. We see that this GPU kernel was invoked by Pytorch operator attend2, which copied tensor from CPU to GPU. But what was blocking this operation? Attend2 was waiting for single process data loader, which was invoked before that, and which was actually loading the data. And while it was loading the data, we see that GPU was actually idle. So this view shows us how to easily create activities and helps us to resolve and see chain of operation and resolve the bottlenecks. Trace view is very helpful for detailed analysis. In addition to trace, we have a couple more advanced views. GPU kernel, which shows the most expensive GPU invocations, and the operator view, which focuses on Pytorch operators. In this particular case, we see that convolution backward in this aggregated view was the most expensive Pytorch operation. We could see also table and sorted by duration or number of calls, and see tensors input shapes for each Pytorch operator. Lately, we also added ability to see a call stack of all code lines that led to expensive Pytorch invocation. Once selected, Profiler would take us to the actual line of code that led to this invocation, which is very helpful for development to take a look at the source code and jump back to the data and all of it in the same VS Code view. To summarize, we have seen how easy it is to use new Pytorch Profiler. Users can easily enable Profiler with a few lines of code and immediately switch to analysis and a resolution of bottlenecks, and it's all seamlessly integrated in VS Code. Now I would like to share additional exciting option for model acceleration that was recently contributed to Pytorch community, ONNX Runtime Training Module. ONNX Runtime is an open source project that is designed to accelerate machine learning across a wide range of frameworks, operating systems, and hardware platforms. ONNX Runtime now accelerates both inference and training of ML models. It becomes especially important for large-scale complex models such as popular Hugging Face transformers and NLP models. It could take sometimes hours and even days to train. Here I would like to show profiling results from training popular T5 large model. While average step time for training using regular Pytorch framework takes about 1.2 seconds, same training steps using ONNX runtime module take us down to 360 milliseconds. That's a significant improvement. It would save both time and money for our data scientists. Our goal was also to simplify developer experience. To use ONNX runtime module, all we need is to add just one line of code, wrapping Pytorch model with ORT module. No other additional changes are required into the original training script, which is extremely important for complex models like T5 large that I'm showing here. So how does it work? ORT module overrides Pytorch module and generates forward and backward optimized computational graphs that run the training in the highly performant ONNX runtime. It optimizes these graphs created from Pytorch model using a number of techniques, such as fusing subgraphs into single operators, performing memory optimizations, and kernel optimizations. And all this power of acceleration is gained with one line of code that users need to add to their scripts. And they would see immediately gains and get the savings. We have demonstrated two projects, Pytorch Profiler and ONNX Runtime Module, that enhance your developer experience using Pytorch on Azure. Sarah will now share some exciting news with you.
Thank you so much, Elena. We just saw a demo of two of our investments in the Pytorch ecosystem, Pytorch Profiler and the ONNX Runtime. Microsoft and Facebook remain active in the Pytorch community and ecosystem. We're thrilled to announce, as well, Pytorch Enterprise. Microsoft will provide 2 years of support for specially designated versions of Pytorch, starting with Pytorch 1.8.1. While we're delivering a reliable enterprise experience, we will also be upstreaming all of the bug fixes to the LTS Pytorch distribution. That way, everyone in the Pytorch community can benefit. Azure is empowering every developer and is your trusted partner to accelerate your application development. All you need to bring is your imagination. So what are you going to build today? Find out more about open source on Azure at aka.ms/OSS-build 2021 and check out our blog for this session in order to get a deep dive into the cloud native applications and speeding up your innovation cycle with open source on Azure. Don't forget to check out our Open Source at Microsoft page. That's at aka.ms/OSSMS. There you can learn more about the projects that we're contributing to and the foundations that we support. Thank you, and enjoy the rest of Build.